So let's have a look at Leaving Cert, question 12 part C from 2009. This is one of these half questions that are very popular. It's 28 marks. Should take you about 10 minutes to do it. So let's have a look in our notes at this particular question. So it's a question on optical fibers. So information is transmitted over long distances using optical fibers in which a ray of light is guided along a fiber. Each fiber consists of a core of high-quality glass with refractive index 1.55 and is coated with glass of a lower refractive index. So what are they asking me in the first part of the question? They say explain. So you've got to write something and you've got to draw a label diagram how the ray of light is guided along the fiber. So let's have a look at this question in detail. So here's your diagram. So you just want to draw your glass fiber, and just on the outside of it, you're just going to put in that kind of line that's shaded. That'll represent a material of lower refractive index. Now, they want to see the ray of light getting guided along the fiber. I'm going to send in a ray of light, but it's really important that when I send my ray of light in, I send it in at an angle of incidence that's greater than the critical angle. And what happens when the angle of incidence is greater than the critical angle? You get what's called total internal reflection. So that ray of light will bounce down and it'll bounce along the fiber. So there's 9 marks for this question. We get 6 marks for actually drawing my diagram and showing that ray of light getting reflected at least once. Now, it says explain as well, so we just have to say a few little words, not too much. So something like this: send a ray of light into the fiber and this is important, I need to say this, at an angle of incidence greater than the critical angle. That's important. At an angle of incidence greater than the critical angle. And then what happens as a result of that? Well, as a result of that, you get total internal reflection. So, total internal reflection occurs. You know, that's nice and simple, isn't it? I'm just giving you one sentence, really. That's all I've done. The important thing is, when you give your explanations, put in all those key terms that you get in your notes. So what kind of key terms did I get there? Well, I mentioned angle of incidence. I mentioned critical angle. I mentioned total internal reflection. So get them into your answer, because that's what the marking scheme is full of. It's full of those keywords, and when the marker sees those keywords, you get your marks. So basically 9 marks for that, probably 6 marks for the diagram showing the ray of light getting reflected, and 3 marks for the explanation. But get those keywords in all the time, and keep your answers nice and short. Not too short. Always have full sentences. So get those keywords in. They're critical to getting your full marks. Right, back to my question. What's the next part they're saying? They're saying, why is each fiber coated with glass of lower refractive index? Well, the reason for that is it ensures that you get your total internal reflection. I'm not going to go into the detail. They don't require the detail. So why do I coat it with lower refractive index? It ensures total internal reflection takes place. Sometimes I call it TIR, but in the exam I want you to write down the full thing. Ensures TIR occurs. So leakage of light is greatly reduced. So they're the two things that I want to say. The reasons for that, you're moving into from a denser medium to a less dense medium. You don't really need to go into that. You can if you wish, but basically that is my answer. So we're talking about 6 marks for that, probably 3 marks for talking about the TIR, and 3 marks for talking about the leakage being reduced. Now we have the problem part of it. So back to my question. So what is the speed of light as it passes through the fibre? So we've done loads and loads of refractive index problems where we use our table. So our table will take care of every type of refractive index problem. What information do I have? Well, they told me earlier on that the refractive index of glass is 1.55, and down here I have a constant. The speed of light in air is 3 by 10 to the power of 8 meters per second. Well, you know what? That's an older paper. So you know what's going to happen right now? They won't give you that. You'll have to go to your table book to get that value. So we've talked about that already, how you go about doing that. So always have your table book open. Have it open in the middle pages, page 46 and 47, because they're the pages that you're going to be using most often in the exam. So set up your table. We're going from air to glass. So air goes first in your table, followed by glass. What is the speed of light in air? That's normally called C, but I use V's in my formula here. Here's my formula. We're doing all kinds of refractive index problems. So I'll say VA is 3 by 10 to the power of 8. And they're asking me to find the velocity of light in glass. They've given me the refractive index of glass. NG is 1.55. And the refractive index of air, just remember it as 1. It means going from air to air, which is 1. Right, so I'm going to apply 2 parts of my formula to this. What parts? The V parts and the N parts. But remember, the N parts are always turned upside down. So it's going to be VA divided by VG is equal to, and turn them upside down, NG divided by NA. Let me put my numbers in. VA is 3 by 10 to the power of 8. VG, I need to find. NG is 1.55. And NA is 1. So do a bit of cross multiplication. In your head, you have these arrows. And you slide the numbers along the arrows. So I want VG on its own above the line, so slide the VG up. Slide the 1.55 down below the 3 by 10 to the power of 8. The 1 doesn't matter. So put that number into my calculator. So I get fraction 3 by 10 to the power of 8 divided by 1.55. I get this very big number. Turn it into scientific notation. It's about 1.94 by 10 to the power of 8 meters per second. So there's 7 marks for doing that entire calculation. They actually say you won't be penalised for leaving the units out, which I think is wrong. I mean, the units are essential. but that's what they say. But I would always get into the habit of always putting your units in when you're finished. That's really an essential thing that you should be doing. Now we're on to the final part. So let's have a look at the final part. So the final part says, light passing through optical fibers must travel through an enormous length of glass. Impurities in the glass reduce the power transmitted by a half every 2 kilometers. The initial power is 10 watts. What is the power being transmitted by the light after it's traveled 8 kilometers through the fiber? Well, you know what? You don't need any previous knowledge to do this. This is just a little bit of common sense. So it's reduced by a half every 2 kilometers. So after 2 kilometers, it goes down by a half. After 4 kilometers, it's going to go down by a half, which is a quarter. After 6 kilometers, it's going to go down by a half by a quarter, which is 1/8. And after 8 kilometers, it's going to go down by another half, which is 1/16. So in other words, the power has been reduced by 1/16. So you could have said a half to the power of 4. Whatever way you want to do it is fine. So basically, what is the power after 8K? It's going to be the initial power, which is 10 watts, multiplied by what factor has it been reduced by? The answer is 1/16. Put that into your calculator, and we have our answer. So I get 5/8 of a watt, which is fine. If you want to turn that into a decimal, then you've got 0.625 watts. So we have 6 marks for that. So all in all, that question should take you no more than 10 minutes.